Hi everyone, in this video, which is the third part of the series dedicated to the pricing of defaultable bonds with a reduced form model, we will see how to price a bond assuming a non-zero recovery rate. In the previous video, we saw how to price a bond assuming a zero recovery rate. Coupons are paid as long as there is no default, and the principal amount is repaid at maturity in the absence of default. The price of the risky bond is the expectation of the sum of the discounted cash flows. With a continuous compounding, it can be expressed as following, and we obtained this expression for the price of the bond. Now we assume as well that in case of default, the bondholder will recover a part of his initial investment. There is an additional cash flow with the payment of the recovery rate R in case of default. The time of default tau is assumed to follow an exponential distribution, and we obtain this expression for the expectation of this additional cash flow. The price of the risky bond can be written as following, and this makes appear the credit spread, product of the default intensity lambda and 1 minus the recovery rate R. The credit spread is a compensation for bearing a credit risk when purchasing the bond. The default intensity is a measure of the company's default risk. 1 minus the recovery rate is the loss given default. It depends on the seniority of the debt. A senior secured debt will typically have a higher recovery rate compared to a senior unsecured one. A subordinated debt will have a lower priority in the repayment order in the event of default, with a lower recovery rate. With a constant default intensity model, the default rate is equal to 1 minus the exponential of minus lambda times t. It is close to lambda times t with the first order Taylor development, so lambda is close to the 1-year default probability. With no discount rate, the expected loss before t is equal to the product of the default probability and 1 minus the recovery rate. So we see that the credit spread S is very close to the 1-year expected loss. The discounted expected loss before t is equal to the default probability before t times 1 minus the recovery rate only if the interest rate R is equal to 0. If R is different from 0, we have to calculate the expectation of the discounted factor between 0 and the default time tau. Using the probability density function of tau, we obtain this expression for the expected loss before t. Going back to the price, we recognize the discounted expected loss as the last term. It is equal to the product of the credit spread, which is close to the 1-year expected loss, and the risky duration, the duration of the bond taking into account the default risk. So the bond price is equal to 100 plus the risky present value of the coupon in excess of the risk-free interest rate, minus the discounted expected loss before t, which is equal to the credit spread times the risky duration. If the risky present value of the excess coupon is higher than the expected loss, the price of the bond will be above par. If it is below, the price of the bond will be below par. And if the risky present value of the excess coupon is equal to the expected loss, the price of the bond will be at par equal to 100. In the next video, we will compare different measures of credit spreads and we will discuss on model calibration and applications of this pricing framework. Thank you for your time.